Hello and welcome to the solutions video for all of the various assessments that we are doing on February 24th and various combinations of them. So here we go. Our first question, which of the following numbers are irrational? Well, the square root of 0.25 is equivalent to the square root of 1 over 4. That's a half. That's rational. Now, 0.2 squared, we have 4 plus 0.25. 4.25 is an irrational number. You can check, take the square root of 4.25 on the calculator. So the Casio's, when they turn it into the radical form, it's root 17 over 2. If you have a decimal form, it doesn't match, so that one is definitely irrational. 0.125 is rational. Our bottom number here, there's no repeats, but there's also no ellipsis at the end. So this is a terminating decimal, not a repeating decimal, and that makes it rational. Which of the following is irrational? The cube root of 64 is 4. Now, the cube root of a negative number can still be rational. If you have an odd root of a negative, you could still get negative results. But 54 is not a perfect cube. Right? That is 27 times 2. The 27 part is a perfect cube. The 2 is not. 25 over 9, that's the same, or root 25 over 9 is root 25 over root 9, which is 5 over 3, so that's rational. And 1089, the square root of that is 33. We could check that on our calculators. That's rational. Without the calculators, you can recognize that 1089 is a multiple of 9. Pull that out, which is 3. 1089 divided by 9 is 121. That's 11 squared. Now identify the numbers as being either rational or irrational. So 1 is irrational. That's going to include anything with pi. A terminating decimal is rational. 8 is a perfect cube, but it's not a perfect square. So that is irrational. And the 4th root of 16 is 2. Now here, consider these numbered values, the two that are irrational. The square root of 0.64 should be 0.8. Square root of 3 is irrational. Negative square root of 9 is negative 3, but neither 8 nor 15 is a perfect square. And it's recorded in any order, so you can do 2, 4, or 4, 2. Now, ascending order from smallest to largest here. So if we do our decimal approximations, the square root of 20, approximated as a decimal, that is 4.472, which is greater than 1.23 repeating. Definitely greater than a negative number. Doing this as a decimal approximation is negative 0.2 repeating. And the square root of 5 is about 2.23. You divide that by 2. And here we are looking at 1.118 and beyond. So going from smallest, that's got to start with 3 because it's negative. I see we don't have a 3 here. I'm going to bet then that they're treating that as positive, which means we have to start with 4 and then go to 2. You know what? I don't see that here either. Okay, this is 1. I'm going to have to go through and verify the answer key. Doesn't look like we have a valid answer here. So if I look at our answer key, so they're saying it's B. So they're saying it's 0.12323 repeating, then it's 3, then it's 4, and then it's 1. And I don't know how they came up with that order at all. We have our decimal approximations here. It should be negative, so it should be 3, 4, 2, 1. Let me pause the video while I fix this on the assessment itself before moving on. All right, continuing on to our next section. All right, so these numbers ordered from least to greatest. So we have the fifth root of 5. We have a negative number, so that negative cube root of 30. This negative is outside the brackets, so it applies distinctly from the cube root. Even if it didn't, cube roots would still have negative numbers. So that negative has to come first. Now with the negative 5, you square that one, it's going to be a positive 25 because that negative is inside the brackets. So that has to be where we're ending. So we have a negative 1/3 here. This is going to be 1/4. The fifth root of 5 is going to be greater than 1 because 5 is greater than 1. It's pretty close to it, so it's probably going to be not far from 1. Yeah, it's about a 1.3797, yada, yada, yada. And 25 is the greatest. And now here we want to simplify. We've seen very similar problems in the past. So looking at our first one here, this 9, or the negative in the denominator, is not going to cancel. 9 over 3 becomes a 3 in the numerator. Now we have an x squared and an x to the 5th. That makes x to the 7 in the numerator, divided by x3 in the denominator. Oh, no, our denominator is squared. Hang on. I missed that. So this whole thing is wrong. That square in the denominator is going to make a huge difference. Now that's a positive 9 over a positive 9. It's x to the 7 over x to the 6, which leaves us with just a single x. Our numerator is y to the 0, because we have a negative 4 and a positive 4. That leaves us with a y squared in our denominator. So a becomes x over y squared. Now b. So we have a negative 5 over 2. So in the case of the x's, so we're going to have a negative 2 times a negative 5 over 2. That's going to give us an x to the 5th in the numerator. Now a y to the negative 3. And then we have a negative 5 halves here. That's going to be a 15 over 2. I can use the fraction to make that look nicer. So that's our x and y. We could just multiply those exponents, and we have our positive exponents there that we're looking for. Now, our 5 and our 9. In the case of the 5, that negative exponent is going to bring it down here. But that is going to be 5 exponent 5. So that is 3,125 if I've done my mental math correctly. And then we are still going to have the 1/2 left over. So it'd also be the same as 25 root 5 when you have that 2/5. And I'm putting the 5 in the denominator because the 5 in the bracket has exponent 1, but the exponent on the outside is negative. Similarly, it's going to put our 9 in the numerator, but that's a negative 5 over 2. So the negative brings it to the numerator. The 1/2 is a square root. That makes it 3. So our numerator is going to be the same as 3 to the 5. Now I will accept 5 to the 5 halves or 3 to the 5. 3 to the 5, if memory serves. Yeah, 243, because 3 to the 4th is 81. Okay, so that should take care of these. Again, just going to take a moment to double check our answer key here. Okay, and next So what is the product of the following polynomials? Well, a negative x times a negative 2x is going to be a positive 2x squared. Only one of these start with a positive 2x squared. Okay. Now this one, multiply and simplify the following using any method. So I'm going to take it line by line. Our first line, I'm just going to multiply everything by x, and then go through and multiply everything by negative 3. So we have a 2x cubed plus 4x squared minus 7x. That's multiplying the second bracket entirely by x. Now multiplying by a negative 3, that's negative 6x squared, negative 12x plus 21. So that's our first line. Really should have an equals at the start there. Our second line, we collect like terms. It should be 2x cubed. Now we have a 4 minus 6x squared. That's a negative 2x squared. Negative 7 and a negative 12 is a negative 19x plus 21. All right, so that simplifies this one. Multiplying these polynomials, a negative 8h times a negative 9h gives us a positive 72h cubed. That narrows it down to A or B. Negative 8h times 4h, negative 8 times 4 is a negative 32, and the two h's combined to make h squared. Double checking our last term in case there's a mistake along the way we missed. Negative 8h times negative 9 is a positive 72h, because negative times negative is positive. Now this product, a times a is a squared. We're good on that one. Negative 6b times a positive 4b is a negative 24b squared. Now we're down to b or c. The coefficient of our 6 is negative. That's going to overpower the positive 4, so we can argue it's going to be the negative cross term. If this was written response, we had more, we'd have to explicitly go negative 6b times a is a negative 6ab, positive 4ab, negative 6 plus 4 comes out to the negative 2. All right. So again, popping over to our written response to verify. Should have all right, I'll have to check the value of some of these questions here. We should be at 15, but it's showing out of 17. All right, the confusion seems to be that this was giving credit in some cases for basically partial credit on multiple choice. So some of these questions were not out of 1. That was why it was out. Anyway, that is corrected for Monday's assessment. Now, RF1 here. The temperature of a solution was taken over a 60-minute period. The results were graphed in a scatter plot. Which of the following scatter plots show the line of best fit? So that's the line that comes closest to the data. This one I could see being a little bit tricky. D is actually a little bit better than B. A and C, we are not hitting the lines. So those ones we can rule out. If you look closely at B, you will find that there's more points quite a bit above the line than there are below, whereas D is a little more balanced. So B, I can understand why a student might pick that one, but D is the best answer when you look at how close it is to all the points on average. Now 3, which of these fits it? Okay, so the vertical growth of a tree, well, trees are going to grow incrementally over time and keep going up. So A is the one that's always increasing. Calgary's daily mean temperature. This is one If it's a daily mean, it's going to go over a year. Warmer in summer, cooler in winter. The graph really should line up on the left and the right. If it's cyclic, it should end up. Maybe they're just representing climate change by having it a little bit warmer at the end of the year than it is at the beginning. The temperature of a cup of hot coffee as it sits on a table. This is going to gradually increase. So that's B. And the height of a bungee jumper after a jump. Well, they're going to go up and down and up and down. So that's D. All right. Now, the graph shown below indicates a relationship between the distance from home as a function of time as Jaspreet went for a jog one day. Describe a possible situation for each segment of the graph. So we have it's starting at point A, so not starting from home, relatively low slope going across, then a horizontal slope, and then a steeper slope down. So A, walking from start to, let's call it a bench. Right. So that'll be the line connecting points A and B. I have to do annotation off for the up and down arrows to work. B to C, taking a rest by sitting on a bench, and then C to D, jogging home. Takes less time to go from C to D than it did from A to B, even though A started a distance from home. So he's got to be going fastest in CD. That has the steepest slope. The slope is negative, but that's because the distance from home is dropping. So Jaspreet is jogging towards home, whereas the distance away from home is the positive direction. So that's our distinction there. So again, just quickly check our written response answer keys. All right, so that has been cleaned up a little bit. Turns out that these, even though it says 0.5 marks each, someone had to be doing that manually because written response only supports whole number marks. So they were at as 1 on this end. In any event, that's been corrected by actually turning that into matching. So you'll see it as multiple choice rather than written response. Continuing. A function is always a relation. And a function is an example of a relation. A relation connects two sets. A function does so in a way that the input produces unique output. So for each input, there is exactly one output. Now, which of the following statements about the above graph is true? It can't be A, because it does represent a relation. If you can graph it, it's a relation. The graph represents a relation that is a function. That relation shouldn't be plural. Graph represents a relation when it's not a function. No, this passes a vertical line test. And you cannot be a function but not a relation, because every function is a relation by definition. So it has to be B. Now the following table of values. As x goes up by 2, y goes up by 4. So we would have 8, 13, and 10, 17 going up by 2 each time. It's the 13 and 17 I'd be really looking for. So how can we express that? Well, if it goes up by 4 each time, then that means our slope is 4. So we have y equals 4x. And now we need our y-intercept. Well, and actually it's not 4. When x goes up by 2, y goes up by 4. So if x goes up by 1, it's 2. Right? 5 minus 1 is 4. 4 minus 2 is 2. 4 divided by 2 is 2. 9 minus 5 is 4. 6 minus 4 is 2. 4 over 2, that's 2. So it's 2x. If we step this back 2 more, it's going to go down 4. Our y-intercept is minus 3. That is the slope-intercept form. On the other hand, this doesn't specify form. You could use our other forms. So For example, once you recognize slope is 2, you could pick a point on that graph and just fill in your slope point form for those points. That works too. So you can do it also with 5, 4, 9, 6, 8, 13, 17, and 10. You can do any of these combinations. Now, this one, yes, the graph represents a relation. The range does not go from positive 4 to negative 4. If it did, it would come all the way down to here and all the way up to here. The domain actually does... the issue, why D is incorrect. Yes, it tops out at plus or minus 4, but these are strictly less than, not less than or equal to. And it does actually hit the minus 4s. And finally, it is not a function. It fails the vertical line test. So checking our answer keys again. Okay. All right. So far, so good. Moving on. Of the following relations, the 3 that are linear. Right. We've got a 3-digit answer in any order. Well, relation 4 immediately jumps out as being linear. Relation 1, well, that is a linear relation in slope point form. So they said there's 3 that are linear. 3 is a curved line. That is the definition of nonlinear. Relation 2 has an x cubed. That's not linear. So it's going to be a table of values. In each case, the x's go up by consistent values. So do the y's change by consistent values? Well, they do in 5. In 5, for each time x increases by 2, y decreases by 7. For 6, they don't. X increases by 2, y increases by 0.6, then 0.5, then 0.4. That's not consistent. So a linear relation has this set of ordered pairs. An equation showing the relationship between the variables is, again, this variable should be plural. So as each x goes up by 1, so does our y. So we've got y equals x. Now, we don't have our y-intercept. We could figure it out. Again, the type of equation is not specified. We could pick any of these and do it in slope point form. Now that we've written it in slope point form, you can always just add 1 to both sides and see that y is x minus 3. So here is our equation in slope-intercept form, but slope point form, standard form, these are all acceptable. Number 12, if the slope of a hill is 0.6, well, that means our rise over run has to be 0.6, or in simplest terms, 3 over 5. Our third option is exactly 3 over 5. The other ones, well, B, D, and F. These are not multiples of 3, even though everything's an integer. So they're not going to reduce to 3 over 5 in lowest terms. This would be 3 over 2. And this is 6 over 5. It doesn't simplify. So C has to be the correct one. Now the function, if the function below, what's our y-intercept? That's the easy one. You let x equal 0. You read it right off of our form. This is slope-intercept form because that y-intercept is right here. The x-intercept is when y equals 0. So that's going to be the same as subtracting 10 from both sides. So negative 10 equals 6. Or negative 10 equals 6 times x. Divide both sides by 6, you get a negative 10 over 6. But those are both even numbers. That reduces to a negative 5 over 3. Again, a brief pause to check our written response. Okay. So now we're going to estimate the y coordinate when the x coordinate is 2.5. Well, 2.5 is halfway between the 2 and the 3 line. That's going to look pretty darn close to 3. Over the course of a year, Takashi tracks how long he studies before each test to determine how studying affects his test scores. In this example, the dependent variable is. That'll be the test score. He can control the hours studied, so that's independent. He cannot directly control the test score, so that's our dependent variable. Which graph is best described by the linear relation y equals negative x plus 3? Well, this is going to be something with a y-intercept of 3 and a slope of negative 1. So we have both b and d would have y-intercepts of 3. C may as well. Sorry for the noise there. A is out because it has the wrong y-intercept. The other 3 look like they're valid. So the question is, which one has a negative slope? So it looks to me like B is the one with the negative slope. Or a negative 1 for the slope. We can find 2 points and run with it. Actually, the answer key here says C, so I may have messed that up. So this would be 0 and 3, which would be accurate. Another point here, 1 and 2 is done by 1. The answer key says C. You know, I think it should be B. C is the same line. I don't see any way to distinguish between options B and C here. So I will have to replace that with a similar question or adjust the answer key accordingly. Regardless, the answer key is looking for C. Those do both fit. We don't have any correct answer there. So I'll have to adjust that question before it goes out. Now, which linear relation is represented by the following graph? All right, and actually before we get too far into this one, I had just paused it to check the answer key. This question has been rewritten to say select all graphs, which are described by the linear relation, and each of the 2 graphs that fit it, in this case B and D, they're worth half mark each, or you get 1 full mark if you select both. Number 16, which linear relation is represented by the following graph? Our y-intercept is 7. That narrows it down shockingly quickly. Only one of these has a y-intercept of 7. You can also verify that the slope will be negative 2. When we have a drop in 2 from 7 to 5, we have a run of 1 from 0 to 1. So our slope is negative 2, our y-intercept is 7. Now, a soccer team is holding a car wash to raise money. Here's our number of washes, and here's our revenue. So the independent and dependent variables are, right, well, the number of cars that come in are the choice. So the independent should be the number of cars washed, and the dependent should be our revenue. So just, again, double checking our answer key. We should be okay. Let's see, yes, next question. State the domain and range for the relation using interval notation and set notation. I'm going to zoom in a little bit here so we can more accurately read it. All right. So our interval notation of domain. X is an element. For interval, we have the round bracket. Sorry. We go from -3 to 4. Another way to represent that is to say -3 is less than x, which is less than 4. For our set notation, so x is a member of the set, which includes x such that, right, I don't want the full absolute value. No, I don't want that either. Let me check my brackets lists. Do I have one that's interesting? Yeah, we got the left brace. We don't have the vertical bar, which is my preferred notation for this. We'll use a comma. So this is the set of all x such that we go from -3 to 4. There's our ways to write the domains. The range. Now this one is a little bit different because this comes all the way down to 0 and goes up to 1, 2, 3, 4, 5, 6. But at the top, it's a round bracket because those are open circles. So that's 0 to 6, which is the same as saying 0 is less than or equal to y, which is less than 6. Or again, y is an element of the set of all y such that 0, I hit negative by accident, so 0 is less than or equal to y, which is less than 6. There. Now we can zoom back out. Using the table shown, we need our domain and range. So our domain here, we should zoom back in, but it goes from -1 to 5. So our domain is box 1, and our range goes from -4 to 2. That looks like option 6 with our two notations. So just going to pause again while I check our written response. All right, and still good so far. So now the equation of a line defined in this notation. So this is our slope point form. Our slope is -1/2. Your point is -15 and 1. A line perpendicular to this line would have a slope of 2. Well, the negative reciprocal of -1/2 is a positive 2, so that's true. The line will fall to the right. The slope is negative, so that's true. The line has a slope of -1/2. It does, it's right there. That's true. The false by process of elimination is D. We can also logic it out. The y-intercept is probably not going to be 1/2. Not if y is already -1 when x, or y is +1 when x is -15. That's going to bring it 7.5 points down from 1 by the time x gets to 0. So it's not going to be that y-intercept. Now this one, what's our slope given this equation? Well, notice how we have not y equals, but 3y equals. So the slope is not 15, it's 15 divided by 3 because we have to isolate our y first. So our slope is 5. Same logic says our y-intercept is -12 divided by 3. That's -4. Now here, the x-intercept of 1x minus ay equals 13. The x-intercept is when y is 0. That means 1x equals 13. So it's 13. I think these are randomly generated, so if you see 5x minus 12y equals 25, you'd be dividing the 13 by 5. So when our y is 0, it's our constant divided by the coefficient of x. Now, the slope point form of the equation shown could be, well, we know our slope is negative. So that gets us to either B or C. So we have the points -6 and 10, or 10, -6. Well, 10, -6 is a point on the graph. -6 and 10 is not. So we can select B. Just doing a quick check of the answer key. And moving on. We're looking at a line that passes through the points -1, 6 and 1, -2. This might be a little more clear if we graph it. So we have -1 and 6. Zooming out a little bit so we could see it. And 1, -2. Okay, these are our 2 points. We need the equation of the line in slope point form. Well, first off, we need the slope. When x increases by 2, y decreases by 8. So y2 minus y1, 6 minus -2 is 6 plus 2 is 8. -1 minus 1 is -2. So yes, our slope is -4. Now, the most likely responses we're going to get here would be based on the points that we're given. So it could be this. We could also have y plus 2 equals -4 and x minus 1. So these are the 2 points we're given with that same slope, -4. Either of these is acceptable, and frankly, it's written response. You could do any point that's on the line if we have that slope of -4 and your point is anywhere on the line. Right, we can actually double check these. They'll do y minus 6. Actually, if you were checking these in your calculator, you'd have to isolate y, but you don't have to simplify. So for example, if we take this first one and add 6 to both sides, we'd have y equals -4 x plus 1. And we just add 6. We see that passes through our points. If we did our other form similar way, x minus 1, and here we'd be subtracting 2. Again, lines up perfectly. So you could even say that y equals -4, our y-intercept is 2. There's a number of points you could use on this. That gives us our slope-intercept form. It's -4x plus 2. So that part we have. We can see that either from graphing or by saying, well, if we're exactly halfway between -1 and 1 to get 0, we'd be exactly halfway between 6 and -2, which is positive 2. Now, general form, we can have 4x plus y equals 2. I will also accept 4x plus y minus 2 equals 0. So different sources will say they equal to 0 or equal to a constant, depending on what you're focused on, whether it's a conic section or a standard form for linear algebra. So these are the 2 acceptable versions of this answer. Now the equation of the function in slope-intercept form, which has a slope of -5/2 and goes to the point 6, -6. So this one is best to do algebraically. Slope of -5/2 and 6 minus 6. So I'm going to put down our slope. And our point is 6 minus 6. So that means our slope point form is y plus 6 is a -5/2 x minus 6. Here we are looking for our slope-intercept form. So that's a y plus 6. If we multiply this through, we have a -5/2x. The 2 can be a factor of the 6. So this becomes negative times negative is positive. 15. Negative 5 over 2 times a negative 6 is 15. Now we subtract 6 from both sides. We get negative 5 over 2x plus 9. So we go a negative 5 over 2x plus 9. That would be A. And here, the equation of the function in slope-intercept form that has a slope that. Okay. We've got some duplicates in the database. They have different randomized ranges, but they seem to have randomly selected the same parameters this time. So I will tweak those to make sure that they can't. So now, if f of x is 32, the value of x to one decimal place is, that means y is 32, not x. So we're not doing 32 times 5 to get 160 and subtracting 9. We are saying a 32 equals 5x minus 9. What x is that? Well, that's 41 equals 5x. So it's 41 over 5. But again, it's asked for one decimal place, so that's an 8.2. We have permission to use decimals here. Now, if we substitute for x equals 15, that's what we have in this notation. 5 times 15 is 75, minus 9. We are at 66. The value of f of 1, if x equals 1, y is 2. Doesn't matter that we haven't graphed absolute value functions and won't until Math 20. We could just read that off the graph. You don't need to know how to do it algebraically to solve that problem. So now f of 1 is negative 1. If f of x equals 3, so when y is 3, what's a possible value of x? Well, that would be negative 2. It's not quite at the peak, but we don't have anything else that's in that neighborhood. All right, lastly, the graph below that best represents the system of equations written below is. So our best bet here is to look for our y-intercepts and our x-intercepts. Our first graph, 3x minus y minus 1 is 0. If y equals 0, we have 3x minus 1 equals 0, or x equals 1/3. So A and B seem to be contenders there. They, in fact, seem to have the same blue lines, so that's the same as y equals negative 1. So these two have graphed the 3x minus y minus 1 equals 0 correctly. Now, which one graphs the second one correctly? If x equals 0, y equals 4. So that tells us we have a y-intercept of 4, which they both do. Now, for y equals 0, x is 2. That's this one. So the equation ax plus by equals 26 passes through the points 3, 5 and 10, negative 44. So how do we solve that? Well, that gives us our linear system. So if it goes through x equals 3 and y equals 5, then we have 3a plus 5b equals 26. Our second one goes to the points 10, negative 44. 10a minus 44b still equal to 26. Now, whether we use elimination, substitution, the method from here is up to you. I am going to use elimination here. So I'm going to multiply our first equation by 10. So that leads to 30a plus 50b equals 260. Multiply our second equation by 3. That's 30a minus 132b And 226 times 3, that's 5278. If we subtract the bottom from the top, we eliminate our A's. We have 182B, because 50 minus negative 132 is a positive 182. And 260 minus 78. That's going to end in a 2. We've regrouped. So 5 minus 7 is an 8. We've regrouped 182. So B is 1. And if B is 1, well, in the first one, that would say 3A plus 5 is 26, or 3A is 21. A would be 7. Checking that here, 70 minus 44 is 26. So A is 7, B is 1. Now, the Y value for the system shown here, we have a negative 9x and a positive 9x. This is tailor-made for elimination. If we add these two up, we get 11y on the left and 121 on the right. That tells us y is 11. And that's all we're asked for. We were not asked to solve for x. In this case, if y is 11, that would be a negative 99. So it looks like x is 11. Would that be the case? 11 or x. If y is 11, that's a 22. Yeah, it seems they are both 11. Here, a student wanted to use elimination to solve the following system. To eliminate the variable y, what would you have to multiply the first equation by? Massive red flag here. We're not trying to get from 4 to 33. This is not written in standard form yet. The negative 12y is on the wrong side of the equation. We have to rewrite this to say x plus 12y equals 33. So to get from a negative 4 to 12, you can multiply by a positive 3 or by a negative 3. The answer key should accept both of those. Okay. So at least I think I have it set up that way. If it doesn't show up that way, let me know. All right, so shopping for a day at the beach, you put 5 nectarines and 3 apples in your basket. You pay $3.90. When a Fred texts to say only 2 more apples, you get 2 more apples and pay $4.50 for 5 apples and 5 nectarines. We need the cost of nectarines. Well, what we figured out is adding 2 apples adds 60 cents. So the apples are 30 cents each. So that means 3 apples are 90 cents. So the 5 nectarines were $3. So a nectarine has to be 60 cents. If you put 0.60, you're answering in dollars, not in cents. That is worth partial credit, but not full credit. So give me a moment just to double check the answer key on these last few and to mark that last set of written response. And we should be good to go. There we are. There's the perfect score we're looking for.